Solving quadratic equations, lesson 2. Today we're going to focus on applying quadratic equations. A water slide ends with the slider dropping into a deep pool of water. The path of the slider after leaving the lower end of the slide can be approximated by the quadratic function h of d equals negative 1/6 d squared minus 1/6 d plus 2, where h is the height above the pool and d is the horizontal distance that the slider travels from the slide. Both are in feet. What horizontal distance does the slider travel before dropping into the pool? So we're looking to solve this equation. Let's rewrite it as an equation instead of a function. We then have 0 equals negative 1/6 d squared minus 1/6 d plus 2. Now with fractions it makes it difficult to solve, so I would suggest that we get rid of our fractions. I can get rid of fractions as long as I multiply everything on both sides of my equal sign by the denominator. So I'm going to multiply each piece by 6. Actually, let's make it negative 6, and then we'll get rid of our negative sign as well. Negative 6 times 0 is still 0. Negative 6 times negative 1 is positive 6, divided by 6 is 1. So we end up with just d squared from that first term. In the next one, negative 6 times 1 is negative 6, divided by 6 is positive 1. So plus d. And negative 6 times 2 is negative 12. This is a much nicer equation to be working with. To solve this quadratic equation, we need to factor the right-hand side. D squared plus d minus 12 will factor into two factors. One where it's d plus 4 and one where it's d minus 3. Remember that you can use your box method to help you factor. We now want to take each of those factors and make them equal to 0. And solve for d. The first one gives us d equals negative 4. The second one, d equals positive 3. If d represents the horizontal distance, we can't have a negative distance, and therefore we can't have the solution of d equals negative 4. So we're going to discard this one. I want to verify then that my answer is positive 3. So I'm going to substitute d equals 3 into my equation. Now I would suggest you want to substitute it into this original equation in case you've made a calculation error along the way. So I'm actually going to do that verification over here where I have a little more room. So I'm going to put in 3 for d. So I have 0 equals negative 1/6. Instead of d squared, I have 3 squared minus 1 over 6 times 3 plus 2. This gives me 0 equals negative 1/6 times 9 minus 3 over 6 plus 2. This is negative 9 over 6 plus 3, instead of plus this should be a subtract, 3 over 6. And then the plus 2, if I write it as a common denominator of 6, would be plus 12 over 6. Negative 9 minus 3 plus 12 does give me 0 over 6. So therefore, I've verified that equation. This example is a little bit different. We're not given the quadratic function and we need to create it. It says the area of a rectangular ping pong table is 45 square feet. So I know that my area is 45. The length is 4 feet more than the width. What are the dimensions of the table? So if I'm drawing my picture, if this is my width, my length is 4 feet longer. So it is the width plus 4. To calculate area, we want to multiply length times width. So I can write an expression as width times W plus 4, which was my length. I know that the area is 45, and I can then do some simplifying on this right-hand side. I'm going to multiply the W in, and I write W squared plus 4W. To write it as a quadratic equation, I'm going to move the 45 onto the other side, so subtract 45 from both sides. And I have 0 equals W squared plus 4W minus 45. To find the dimensions of the table, I need to factor that quadratic equation. So 0 equals, and my two factors, using my box method or another method, I can find my two factors to be positive 9 and negative 5. Making each factor equal to 0, I have W plus 9 equals 0, and W take away 5 equals 0. This first equation gives us the root W equals negative 9. The second one, W equals positive 5. Again, we're going to discard this root of negative 9 because we don't talk about a negative length. Therefore, my width would be 5. My length, we said, was W plus 4. So therefore, it would be 5 plus 4, or 9. I should also verify my solution. I can verify by substituting in 5 for W. So my equation was 45 equals W squared plus 4W. So 45 equals, W was 5 squared plus 4 times 5. So 45 equals, 5 squared is 25, plus 20, 20 plus 25 is 45.